Hey guys, I got a message from Lee this week, this one, followed by this one, and with a bit of back and forth it led to this one. Now, I thought it maybe would be a good idea to create a video series where I would tackle your problems, where you're stuck on code or anything else, and I try to see if I can come up with a solution, explain how I came up with it, and perhaps even give you some alternatives. So in this video I want to focus on his question for a VR box that is going to be 2 rotary encoders and a button. So it's going to be something that's going to be small, easy to control when in VR, because you can't see the rest of your desk, right, when you have the glasses on. So yeah, we're going to see how it works. It's going to be a bit of a longer series because I'm going to really explain how I implement it and how the code works. So I hope you guys learned something from it. Perhaps you even have better suggestions. Let me know in the comments. If you want to see something realized of your own, send me an email to info@bitsandroids.com or hit me up on Facebook, Instagram, whatever, and I'll see what I can do.
Now for this project I'm going to use a breadboard. I'm going to use an Arduino Nano. I've put it on a small cutest breadboard ever. We need 1 push button, a boatload of cables, male to male and 4 male to female, just if you want to use an LCD screen. And we need 2 rotary encoders. Now it depends a bit on if you have dual concentric rotary encoders or just 2 rotary encoders. I went with 2, 1 to dial the frequency, etc., and 1 to dial the mode if I don't want to use the button. Now the Arduino Nano looks a lot like the Arduino Uno. It's this, but in a smaller form factor. It can be powered with like this ancient USB port, but it still works, right? We have some digital pins and analog pins, but we're going to mainly use the digital pins. Now the rotary encoders have 5 pins, a ground, a power, a switch, a data and a click line. So the only pins that need to go to the board are actually the switch, click and data pins. So that's going to take up 3 pins on our board per rotary encoder. So we're going to need 6 pins for the rotary encoders, 1 pin for the button and 2 pins for the LCD screen. Now the button works, you see the 4 pins. If we press it, the left side is going to be connected to the right side. And we're going to connect it using the internal pull-ups of the Arduino. So we're going to use the input pull-up mode. So we only need to connect the ground and 1 of the ports on the Arduino. Now the LCD screen is mainly going to be in there for debugging purposes. So I just grabbed an old one. I'm going to use one with an I2C interface because it only takes 2 cables and a power and a ground one. Now we're going to start by putting everything we need on the breadboard. Now where we put them doesn't really matter as long as they're not on the red and blue line on the front and the back. So something like this works fine. Here we can see that we got the rotary encoders on one side and we actually bridged the gap in the middle with the button. Because we want to use it as a VR box and we want to keep things rather small, we're going to start wiring things up because this is all we need. I'm going to be using the 12 gauge single core wire for some of the parts, and it's just because so you can easily see what is going on without having these long cables in the way. You can just use the pond cables that are laying on top. The first wires I always like to connect are the power wires because they are just running to the common line, so they go from the plus pin on the rotary encoder to the red line in the back. Next up I will do the ground because this will be the same, it goes to the common line in the back for the rotary encoders and for the buttons as well. And once again at the front we can easily see where each cable needs to go, so the ground goes to the ground, to the blue line in the back, and the plus is the power to the red one. Because we want to use the internal pull-up resistors of the Arduino Nano, we can wire the button straight to the ground line, so either the left or the right side. It doesn't work with the top or the bottom side, you have to do left or right. Now where we hook things up on Arduino doesn't really matter for the digital pins. So I'm going to be using pin 2 and 3 for the rotary encoders and 5 and 7. I accidentally skipped the 6 later in this video, so because it's a voiceover I can do what I want. But we do need the analog 4 and the analog 5 for the SCA and SDL pins for the LCD screen. The ground and 5 volts from the Arduino board go to the ground and power of the breadboard, as we might see. And we can start hooking up the rotary encoders to our Arduino. At first I do the switches, which gonna be at, I believe, D6 and 7. Okay, here we're able to tell that we connect the switches, so the blue wires. And if you get lost, you can look at the front to see where the SW is located for the switch. We connected them to 6 and 7 on the... So because I want to keep things color-coded for you guys, I grabbed my collection of little wires, and it goes from the data pin to either port 2 on the Arduino Nano or port, let's see where the other one is connected, port 5. So the yellow ones, the data, go to port 2 and port 5 for my... Well, last but not least, we're gonna hook up the click wires, and there's going to be port 3 and 7 because I actually intently skipped 6, but if you want to change it in the code, you can change that to 6. But if you just want to follow along with the code, please plug it into 7. If you do this on your own and don't look at my code or anything, you can put them any way you want, whether an A or a D is noted. And that's actually all we need for the rotary encoders. The only thing that's left is to hook up the button and the LCD screen. Because we use the internal pull-up resistors of the Arduino, we only need to connect the button to pin 12 and of course the other end to the ground, and that leaves us with just the LCD screen to hook up. Now the Arduino Uno has a dedicated SDA and SCL pin. The Arduino Nano doesn't, but you can use the analog 4 pin for the SDA, SCL, sorry, and the analog 5 pin for the SDA. So that's the green wire and the yellow wire coming out of the LCD in my video, and the power can just be connected to the common power line and the common ground line. Now the end result looks something like this. We need quite a lot of cable for this, but it's still very compact. LCD screen, 2 rotary encoders, and the button are all hooked up. So the only thing that's left now is to plug it in and see if it works. Power is on, so let's just start with programming, shall we? Okay, so how are we gonna code this thing up, right? There are a few things that I set out to do. A, it has to be used in VR. So I have 2 options to change a mode. So because in VR you can't be looking on your desk everywhere where the button is. You can of course place them on the exact same spot as in the game, but I still think I'm not sure because I have not played it in VR, but because you can't see your hands, it's still going to be a bit weird if you have to reach around, look for the right buttons, and before you know it, you mess it up. So I wanted something compact, and that is why I went with this small little setup. And I wanted something that could reliably change a mode on your desire. Because the question that got asked me is to create something with 2 rotary encoders. One to change a value, let's say the COM port, nav port, radio, etc. I want to change the mode. Now I got that working, so I made 2 options actually. One with rotary encoder changing the modes, and the other one with a button and with key press commands. Like 1 click in X frame of seconds is going to be the nav mode, 2 clicks is going to switch to COM mode, 3 clicks is going to switch to whatever. And you can be as crazy as you'd like with it. That's something that I'll leave all up to you. It's just 2 approaches that I took for the same problem. And I just wanted to share with you how I got here and what we programmed and how it works. So if we see, let's see if it works. Shall we? So what I've done is that if I press once, it's going to go to COM mode. If I click twice, it goes to nav mode. If I click thrice, or 4 times this time, I'll go to alt mode, and 3 times go to heading mode. Now I could make a switch that would just go through all of them one by one, like they do in this one. See? Here we go. It just goes next, next, next. But the problem is you always have to scroll through the entire list before you get to the desired one. Now, it could be faster if you need to switch only between 2. Then some things that all is fine. If you have a big list, I think this is actually quite a smart approach. Right now I've went with an approach where I had just a set interval and counted the clicks. But there is also the possibility to count actually if there are long clicks, short clicks, whatever kind of combinations. to really create some kind of input interface with key commands that are time-based instead of just a list that it iterates through. Now, apparently we're in Amsterdam. No, apparently we are in Amsterdam. Quite busy this morning, I see. We don't have these houses on the airport, I think. But correct me if I'm wrong. Got the Beechcraft G58 hooked up. Now, because it's in VR, there is one thing that I already mentioned. You need to be able to tell in-game in which mode you are, right? So let's say if I switch to 1. See what just happened? It says Alt current mode. If I switch, it says nav mode. So it sends a command to the game saying in which mode I am on my Arduino. Something new. I just came up with this because, you know, in Arduino and VR, you need something to visually tell you what's wrong. Now, normally there are better ways to handle this in the old FSX. I don't know, I've never played FSX, but I've read it on the internet. But currently, only this kind of text is supported by Asobo for Flight Sim 2020. So the downside is that if I use the rotary encoder to scroll through them, see, it's changing, but there is a backlog, and now it will go to them one by one, and I have to click them all away if I want them to be gone, etc. That's just because the real text functionality isn't implemented properly yet. So that's why I stick with the button, because it's actually based on the time it takes for a message to come in, and I like it more because it's a bit more hands-on in creating. So let's just go into the code and see how this is made. So I'm gonna grab a new sketch because I'm just gonna do it from the beginning. We're first gonna define our pins, which are 2 for the rotary encoder, so 2 each, 2 for the buttons. We have 1 button, and I believe that was it, right? Yeah. So we just say define button. I got it hooked up to port 12. Say rotary switch B is hooked up to 5, and rotary switch A is hooked up to no, the rotary switch B is hooked up to A7 and A6. Perhaps I put them in the wrong way. I don't know. So rotary A, B, it's the bottom one, B, then A is gonna be 7, and rotary B, pin B, it's gonna be 5. I accidentally skipped a pin on the board. I just noticed. So rotary A, pin A, and we're gonna be doing the rotary A, pin B. So let's see. Now we've got all pins defined. Those are 2 and 3. So here we just defined which pins we have and to what number they are connected. It just matches the number that's on the Arduino. On the analog ports, so the one that are prefixed with an A, we also prefix it with an A in our define. Now in our setup, we're going to be defining these as inputs. Oh, no, that's not. That's just. It's not really necessary because if we only read it, we know that it's just to give it a bit more of form. Give it a bit more form here. Rotary A, input. One, two, three, 4. Rotary in A, B, rotary B, pin A, and rotary B, pin B. So now we know that this always will be an input. It will never be an output. And the switches we're going to define them as well. Rotary. Let's just type this rotary switch A and rotary switch B. Now these are going to be input underscore pull-ups. And here as well, so we're going to use the internal pull-up resistance of the Arduino Nano or Uno, whatever board you use, to control this button. And this makes it really easy to just have it hooked up to an output pin or input pin in this case and ground. Nothing more is needed. You just need 2 wires for a button and it works fine. Now, in order for me to debug, I need to include the liquid crystal library, and that will just drive the, how do you call it? LCD screen. The LCD screen. So we're gonna put that in. And then we need the LCD screen itself. It's gonna be liquid crystal underscore I2C. Just gave it a name, LCD, so this is the name of the object. The address 0x27. Most of the time this will be correct, so you don't have to alter this. So 0x27. We have 16 characters over 2 rows. Now, once again, this is just for debugging. If you don't need it, you can leave it out. It's easier for me when I shoot a video that I can just have a quick glance at what mode is activated, etc. Now, we've worked with rotary encoders before, so we have some things we need to define, like variables. We first need encoder A position. So we need a current position. Now we're going to start at 0. And we're going to say another encoder A pin last. Encoder A pin A last is low. These are just starting states that we can write to in our loop. But we define them already just so we have them, so we don't have to reinitiate a variable every time. And so we place them above the setup block. And we put in a low. Now I'm going to explain these variables in a second in the loop block. It will all be a bit more clear. Now this was encoder A, so now we do encoder B position is going to be 0. And encoder B pin A last. So encoder B, but the pin A of encoder B. Up here we had encoder B, pin A, so not pin B. I hope you're still following along with the pins B and A and encoder A and B. It's going to be low, just like above. And int and B is low. Now, because I've mentioned that I've used a timer for this, we're going to use some time values as well. I'm going to say an unsigned long interval start time is going to be 0. Yeah. No, I don't want to initiate. Sorry. No. And we want a const unsigned long, because this value will never change, right? It's going to be our interval itself. So in my case, I have a button press combination in the 2-second range. So within these 2 seconds, we're going to determine how many times it is pressed. After the 2 seconds, a new command will be sent, right? And I want to see how many times we have clicked. So the press counter is going to be 0 at start. And then we want different modes. Now in my case, I'm went with booleans. Com mode is, let's say that the first one is true. Bool nav mode. Well, if one is true, the others can be false. We're going to have a heading mode. I've just picked some values. You can change these for anything you like. Bool alt mode is false as well. So now we have 4 modes. com mode, nav mode, heading mode, and alt mode. And based on which of these is true, either one of the commands will be sent to the game. Now, if we want to send something to the game, we also need the bits and droids library, bits and droids flight connector. Here we go. And create an object like we did with the liquid crystal I2C. Bits and droids flight connector. Here we go. Connector. False, because it's not a Leonardo Pro Micro. And we have initiated most of the values that we need. In the setup block, we still need to do lcd.initiate. If you want to use an LCD. lcd.backlight to turn on the backlights. We need to have a serial. Serial.begin. And in my case, because I want to use it with the connector, I'm going to be using 115200. And I believe that was it, right? Oh, no. Because we want to know when we start, how do you call it? Input sequel, so how many times we pressed. We also want a Boolean first press, so we know when it started, and that we don't need to restart some things each time, only on the first press. Now in the loop, we have the LCD hooked up, so we're actually going to start by saying lcd.setCursor, and we're going to put it at, let's say 13 and 1, it's going to be this one. And we're going to print something which is going to be the press counter. And this is just for debugging purposes, that if we press it like we do now, we can see it's how many times we pressed, right? Nothing more, nothing less. Here we go. So you can leave it out if you don't need it. So that is it. Now, how do we know if the button is pressed, right? Well, we check if digital read button is equal to low. So if the state of the button is equal to low, so if we press it, do something. Right? Pretty straightforward. Now, we want to do two things. If it's a first press, we would want to do one thing, and if it's not the first press, we want to do something else. So right now, first press is false. So that means nothing has been pressed previously. So we say if not, so exclamation mark, first press. This just checks if this is set at false. So that's where we started with, not with true. False. If it's false, do this. And then we're going to make, if it's true, do this. We're going to say interval start time is millis. Millis. I hate the word. So it's going to put a value of the current time based on the time the Arduino started, but that's not really important. And it's going to save it in the value. It's going to, because we pressed the buttons, we want to do the press counter plus plus. So we add 1 to the press counter. And we set first press, because this will be the first time that we press the button. It's going to be true. So once again, if we press for the first time, it's going to say the interval starting time is now. This gives us a value that we can check later on. Has the interval period passed? Then do X. So that's why we save this value. We do the press counter, because even though it's first press, we still want it to count. +1, and we set the first press is true, because after we click this, the first press has passed, right? So what do we do if the first press actually went through? Here we go. We can actually do else if. we can say press counter plus plus. So we only want to start the timer on the first click. Then we say the first press has happened, and every click after that is going to be the press counter plus plus, just add 1 to the counter. Now when using push buttons, it's always nice to have a little delay, or else it will just fire as long as it's low, because that's what it said. If this read button is low, it will just fire as many times as this block gets executed, and you hold the button, so this can become quite a large number quite fast. Me, myself, I like 200. If you want more fast action, you could lower this to 100. It's all up to you how you intend to use it and your preferences. So what we have now is if the digital rhythm is low, so we got the button push covered. And the only thing it does right now is actually change the press counter. We'll see in a second if we need to do anything more, right? So now we know if the first button is pressed, we start counting the button presses. We also need to check if the period has passed. So we're going to say if first press. So if the first press has begun, so we know a series of actions has happened, right? It started, initiated. We're going to check in the if statement. We're going to check again if current millis. We could also do an and statement, but I like to do it this way for readability, just to make it clearer for you to explain it to you. So we're going to say if millis, so the current millis, minus the interval start time. So the current time minus the start time is going to be bigger or equal to the interval. This checks, here we have an interval, 2000 milliseconds, so it's 2 seconds. If the current time minus the interval start time is bigger or equal to interval, we do something. Well, in this case, I'm going to keep the code clean. So we're going to create a function, process command. Here we go. And we create a function set LCD. Here we go. So the set LCD is a function we're going to create that you perhaps don't need if you don't have an LCD to debug things. In my case, it's just to give you a visual representation. The process command will be a function that handles our inputs. It's going to be a pretty simple function. So don't be afraid if you're like, oh my god, he's going to create functions. It's going to be a void function because it isn't going to return anything. It's going to say process command, because that's the name of it, right? We already set it down here. Process commands, brackets, and line. So here we say void process command, brackets, and we start the function. It's just going to be a switch. It's going to contain the press counter. Now, if you have never seen a switch, I hope it will be clear in a second. Case 1. Case 2. In my case, I want 4 modes and 4 buttons. So I'm going to case 3. And case 4. Now it's always important, and that's why I like to do that as the first thing to do, because many times I had to debug things because I forgot it, is to include a break statement in each case. And we need a default case, which in our case is going to be a break as well. Now, what is a switch? It takes a value. So in this case, the press counter, it has to be an integer. Press counter, well, it's going to be 0 currently, right? This one. If it's 0, it isn't 1, it isn't 2, it isn't 3, it isn't 4. So it's going to be default, and it's just going to break. It just isn't going to do anything, isn't going to set a button, nothing. If it's a 1, so if this value is set to 1, case 1, see where we're going with this? If it's a 2, case 2, case 3, case 4. So here we can define some behavior. So here we can say mode counter is 1. There are way more easier ways to do this. This is a bit verbose code-wise. So It's just to give you a clear example of what is happening. This isn't the cleanest way to do this. And perhaps you even have a better way to do this. Please let me know in the comments below. Mode counter 4. So now I hope it gives a clear vision of what it does. If a 1 comes in with the presses, we set the mode to 1. If a 2 comes in, so case 2 in the switch, we set the mode to 2. Case 3, we set the mode to 3. Case 4, we set the mode to 4. So pretty straightforward. This is actually a bit overkill to do it like this, but it gives a clear representation of what is happening. And after that, we're going to create a mode switch. And now you see why it's a bit overkill. So we created this function. Now create another function. It's called void mode switch. Now the void mode switch is going to be a switch. This time we're not going to use the press counter, we're going to use the mode counter. And once again we have 4 cases because we have 4 modes. We create a break. I'm going to be a little bit lazy. Copy paste. Here we go. 2, 3 and 4 and the default. The default is only contain a break, so if something comes in that isn't 1, 2, 3 or 4, we don't want to do anything. Now once again, this is also a bit of a messy way to do this. But what we're going to do is just going to say if it's 1, com mode is true, nav mode is false, heading mode is false, and alt mode is false as well. Now what we just could do is copy paste. Here we go. Here we go. And here we go. Now here we're going to say false. Here we're going to say that nav mode is true. This one's going to be false. 1, 2, 3. Yeah, and then here we're going to say that heading mode. This one's going to be false. And here we're going to be the alt mode. True, false, 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 false. Yeah, so that's correct. So if the mode counter is at 1, and I'm using this as a separate switch, because I also wanted to, as a function, I mean, because I also want to use the rotary encoder, and that way I can just use the same block of code, because that's what the function is. You can call this, say I want to execute this block from your loop without having to rewrite it, and you only have one space where you have to change things, etc. Like I mentioned many times, why it's always good if it's possible to create a function. Because let's say I created this in the loop function, I would have to create it twice because I have the rotary encoder and the button. Now, if I would want to change case 1, I would have to change it in 2 spots. And there is a chance that these 2 don't match. If I forget anything, change only one thing instead of 2. And that's why it's always nice to use functions instead of using it all in the loop function. So just to walk you through it again, here we check if the button is pressed. If it's the first press, we start the timer. If it's not the first press, we're going to increment it without starting the timer because it's already running. Now, if we reach the point of the process command, I'm going to process the command and set the LCD. And it's important that if we process the command, let's see. So if the timer is reached, we do process command. Where is process? Here we are. Yeah, I did. Big brain lag. Here we go. It's important to set the first press. So if the period is passed, we call this function. So it's important to set the first press to false again. So first press tells us, is a series running? If it's not running, we don't have to check the time, etc. So we're going to put it back to false because the first press was true, timer elapsed, we did something with the counter. Now we can set it back to false and wait for the first press again, right? So that's important to actually do, and don't forget to reset the press counter to 0. See where we're going with this? Here we start the timer, you start the counter. If the period has passed, check how many times the counter was incremented, put it back to 0 and put the first press back to false. Now, I'm going to create a function. I'm just going to copy and paste because it's going to be the debugging purposes. You can find it in the description below if you want the full code for yourself. It's going to be the void set LCD. It's just the LCD screen. Let's see if it's still running. No. It's the LCD values where it says print, .1, and if it's on or off, so 1 or 0. It's a bit of a verbose code. Not really that nice and tidy, but you know, it gets the job done. So we create a function, set LCD. You just Ctrl+C, Ctrl+V this one if you'd like. Change this to something you'd like if you want to use it. Sorry. So if we switched the modes, we also want to display it in the LCD screen. So we're going to say set LCD. And what this does, if a mode changes, it will just change the LCD so far. So we can already see, take a look on how it looks. Oh, I didn't create this yet. That's always important. So it's always important to learn how error messages work. I see I have multiple because I probably made some typos. But first of all, mode counter was not declared in the scope because we have a press counter, but we don't have a mode counter yet. So we say int mode counter is 0. And now that message is going to disappear. It's going to give me another message because I spotted another one if I'm correct. Yeah, see? Sketch expected primary expression before this token. First press is false. Correct. Oh, it was in here, right? This is correct, this is correct, this is correct. Oh, here is an error. See this one. I think this is actually what is messing with this. Rotary B pin A. I think I made a typo there because this is going to be rotary B pin A. Rotary. See, always good. It just tells you what you did wrong. It says I don't know this value. Rotary B pin A. So I went up because I know that I declared it, but I did rotary T pin A. And there is no rotary T, it's a rotary. Here we go. Uploaded the code. Okay, the screen. Okay, we already can see that there is something going on that isn't really what we expected, right? Oh, I haven't defined it. Oh boy, yeah. Pin mode button is an input pull-up as well, so I forgot that part. That's why it thinks it's always running. Okay, so we got it hooked up. That screen is going to be blank in the beginning, except for the counter. Why is that? Because here we set press counter. We never set LCD. The only time we're going to set the LCD is when we've processed the command up here. Mode switch. So the mode is switched. I'm going to set LCD. And this is going to prevent that it's going to rewrite every frame. Only change anything when it's needed. So we're going to click. See counter 1. COM1, heading 0, nav 0, altitude 0. Gonna click twice or 4 times actually. I skipped alt mode 2 times, nav mode 3 times, heading mode. Now this is I think a nice way to actually give you a very precise way to switch between modes, because with the rotary encoder you could be at the end of the list, you want to go to the beginning, yeah, you can skip over, but let's say you have 10 inputs. It's going to be a bit harder to actually switch modes if you are somewhere in between. You have to scan through all of them. Here I can just select what I want. I want alt mode. I can instantly go 1, 2, 3, 4. And I'm in alt mode. COM mode 1. And I'm going to be in COM mode. 2. I'm going to be in heading mode. Nav mode. So that's how you create a time-based event with a counter to check how many times it's pressed. Now the only thing that's left is to implement the rotary encoder. So I already defined the pins. I'm going to start with one, and then I'm going to implement the second one to show you how to switch modes with the rotary encoder. It's going to be pretty straightforward, so don't be afraid, it's going to be fine. So the first thing we do is the new A value, so NA I've called it. It's going to be digital read rotary pin A, because it's new A. It's going to say if encoder A pin A last is equal to low and new A is equal to high. Now I've shown this picture many times. Let's see if I can find it. Oh, this is actually a moving picture. Nice. Here we see how it works. If it goes in one way, it hits the B first and the A first. If it goes the other way, it hits the A first, it hits the B first. Now there is a time in here. Look, they're both in between, right? See, A isn't on, B isn't on. So that could give some jitter on the line, going forward, going backwards. So what this does is it checks if it's a whole step. So if one is on and one is off, and this will give us a bit more stability and jitter, remove some jitter. And that's why I go with this approach. And then I'm going to check. It's a double check actually if digital read A pin A is equal to low. So this will tell us that we made a full switch. If it's low, it means we went down. If it's up, so else, it tells us if we went clockwise or counterclockwise, one of the two. I always forget which one is which. So what we can do here is actually create statements again. If nav mode, we could say connector dot, I don't know, let's do com mode. If com mode, what do we want to do? I'm going to look at my own website. Downloads documentation. Let's see, com. Let's do com to com1, send com1. I say I haven't updated this properly. So I'm going to do just send com1 fractal inc. So it's going to change the last part of the value, and we're going to do that here as well. You could create a function for this as well, but I'm going to do it this way. So if the com mode is on, we're going to do connector.send serial.println, serial.println, connector.send com1 fractal inc. And the same goes. Oh no, we'll just do it like this. Serial.print line. For those of you not familiar with my connector, some shameless self-promotion. Here I can select the COM port. I've got the Nano hooked up to COM port 22. If we do serial.println connector.send com1 fract inc, it will send a command to the game to actually change the value of the radio. And that's because I've included the library on top, the Bits and Droids Fight Connector library, which can be downloaded from managed libraries. Let's see. Bits and Droids Flight Sim library. Include the library. Create a Bits and Droids Flight Connector object. Connect. I always call it connector because it's easy to, just say connector.send com-fract in1. And now if the com mode is on and it registers a click, it will either fractal increase or fractal decrease. Now I'm going to put in one more. The rest is all up to you, to what you need. I don't use VR, so I'm not going to be using this. So I'm not going to really go into the really work this out in full extent. It's just what you like to use, and it's the same principle. You can just change this to if com mode, if nav mode, if heading mode, if alt mode. Perhaps you want to use it for completely different things. All fine with me. These are just examples. So let's go back to the thingy. Let's go. I believe isn't. I need to update this as well. I'm sorry, guys. I totally forgot when I worked on the update to fix this, because this looks ugly, but it works. So we're going to say decrease. Oh no, oh no, 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 this is going wrong. This needs to be here. And this needs to be send com 1 fract decrease. Yeah. So if we're in com mode, we're going to increase the fractal part of the com. If we're in nav mode, we're going to increase the fractal part of the nav, the whole part of the nav. Pretty straightforward. I'm going to show you how it looks. It's going to be decrease. I need to be consistent. I see that I'm very inconsistent on that part sometimes. If digital read. See, sometimes naming can be confusing. It would be better if I called it rotary 0 or 1 and 2 instead of A, because now we have A pin A, and that's really not digital read. Oh. Rotary A pin A is low. Here we go. Oh, here we go. I got one too many, right? Yeah. Okay, so now we're in game. We should be able to tell if I click once that we go into com mode. Now, if I turn the rotary encoder, I don't know which. Oh, I need to start the connector. It's going to reboot. It's going to say 1. Okay, it was stuck in between. Okay, there's something not. Okay, I know what it is. At the end of NA is equal to yada yada yada. We have to make sure that we say encoder A pin A last is new A. So this will save the new value to the last value, so it keeps checking. It replaces the last with the new, and then the next check will be from the new to the last, instead of, if it keeps checking for the same thing, it's gonna trip like you saw a minute ago. Now, if we start it, we are in com mode, right? Now, if we turn it changes the fractal part of the either up or down. Now, if we go to nav mode, so that's twice, right? Yeah. It should change the, oh, here is the nav. Yeah, it changes the active frequency, so that's something, I picked the wrong one, but it's working. We're able to tell it goes up, it goes down. Go back to com mode. Oops, too many times, once. And we can change the com again. If we go to nav mode, so twice, we can change nav. And you can implement any function you'd like towards the rotary encoder. So now we said if com mode do this. You can change this with anything you like. If you have a dual axis rotary encoder, you could double this. If it's the top rotary encoder, change the holes. If it's the bottom one, change the kilohertz parts, or the last 3 digits, etc. So that's all up to your imagination. Now, I also mentioned you can change this with a rotary encoder. So what we do for that is really easy. Just copy and paste this. And we change NB, digital read, and rotary pin B, rotary B pin A last, and B. It's important to really change all of these. So rotary B pin B. Okay. remove everything in the if and the else. Well, rotary encoder B pin is NB. Okay, so this is our second rotary encoder. Really quick and easy. So if it goes up, we're gonna say if mode counter is gonna be 4, right? With 4 modes. So if mode counter is 4 and we are going up, we want mode counter to be 1. So what happens is, if you would keep spinning, it goes to 4, 5, 6, 7, 8, 9, and we don't want that. We want 1 till 4, right? So we say if mode counter is equal to 4, set it back to 1 if you go up, and we do the same thing in the else statement. If mode counter is 1 and we go down, we don't want it to go to 0, -1, we want it to go to 4. So if mode counter is equal to 1 and it goes down, go to 4. So what we do then is mode counter so here we do another else. In the else we have an else. Here we go, mode counter -, and here we Control C, and here we have an else as well. So it looks a bit confusing. In this if we have an if and an else, and in this else we have an if and else. It isn't else. This one is still in the if block, but here we want to plus, so increment by 1. And then we would like to if digital rate, yeah, perfect. We actually want to switch mode. So that's because we created a function, right? If the period has passed, process command is going to call the switch mode. Here we just change this mode counter, and then we say switch mode, and it's going to set the LCD for us, right? Oh no, we got to set LCD in here. Perhaps we got a double, I'm not quite sure. So let's see if this already works. Perhaps I made a little mistake, I'm not quite sure. Okay, I need another. Here we go. Oh, I got the wrong else. Oh, but here we need another one. Yeah, so this part is a bit ugly, but it gets the job done. I will clean this up when I upload the code in the comments. So I was turning on the wrong dial, but if we now change this, we can see that it goes down. If it's going to be 0, so now it's going to be 0. I'm going to put it back at 4, etc. So that's also a way to change modes. Now this is a bit more, especially if I don't have the notifications on, right? So right now I don't have any notifications. If I now switch, I'm in A mode, but I'm not quite sure which mode. It should be in com mode, right? Yeah, correct. Oh, but I switched these around, Dave. What did you do? All right. Okay, so always important to start the connector or else it doesn't do anything, but now we can change with the other rotary encoder. And we're still in this mode. Okay, so keep swapping them around. I need to stop doing that. Yeah, sorry. So now we're able to tell we're in nav mode, com mode, and nav mode. But now we're somewhere in between and I have no clue where I am. So that's the only downside. Okay, now I'm apparently back. So that's why I prefer the button to actually, you know, I always know where I am. Now, there is a way to create menus in game, but according to the documentation, it really isn't implemented yet properly. So we still have to wait for that to work. So a workaround could be, and this will be in the next update. So I create a little function, which is really simple, but it doesn't really get the job done properly currently. So here we go, com mode. I've created a command where if you append a string with 009, I should have made that 007, that would be more, yeah, would be more fun. But if you append it with, prefix it, not append it, 009 and a string to your liking. So in my case, I've selected the mode as a string. If I stop the connector, start the connector, here we go. So now if I change modes with the button, it tells us com current mode. Change it to nav, it says nav mode. And now the downside comes when I start changing it with the rotary encoder. Oh, this one. See how it changes, but it doesn't keep up with the rotary encoder itself. So it works. It doesn't work perfectly. I can't change the length of this. I can't change anything. The way they are implemented right now is the only basic functionality for text. But they're working on it, they said. So that's something for the future, I think. But yeah, that's my little VR approach. If you have a question that you would like to see resolved, or how I would approach it, or you have perhaps a better solution for this, please let me know in the comments. If you liked it, leave a like, and if you want to keep updated, subscribe, and I hope to see you in the next one.